The following manifesto outlines the core conceptual framework of the quantum physics theory by Rodney Kawecki, which challenges conventional interpretations of space-time, motion, and causality. The manifesto of the quantum physics theory. Time as an emergent phenomenon. The central tenet of the theory is a rejection of time as a fundamental independent dimension. Instead, time is posited as an emergent measure of change. In this framework, motion is fundamental. Time is the order or count of events produced by that motion. By treating time as a byproduct of change rather than a coordinate, the theory moves away from the standard model of space-time. Space as a partition landscape. The theory redefines space not as an empty vacuum to be traversed, but as a dynamic, structured field. The carrier force space is viewed as a self-restoring, high-tension fabric. Field topology, every point in space, e.g., a parsec, possesses a unique signature of carrier force tension. Potential wells. Rather than moving through a void, navigation is conceptualized as moving through a landscape of varying intensities where an object's interaction with the field defines its state. 3. The geometry of decoupling. A significant advancement in this theory is the treatment of the speed of light, c, not merely as a velocity limit, but as a geometric boundary, decoupling from the field. As an object approaches c, it becomes effectively decoupled from the causal timeline of the rest of the universe. Vector rotation. The theory argues that reaching the light speed limit involves a rotation of an object's world line. An object with mass, which typically points through time, cannot physically exist on a surface that is purely spatial, light-like, without decoupling from the field that provides its rest mass. Implications for physics. This framework suggests that by uncoupling from the tension of the carrier force, one might reinsert into the field at a different coordinate, theoretically bypasses the traditional barriers of relativistic movement. This shifts the focus of physics from mapping static stars to understanding the topology of the field itself. To explore these ideas further, you may find this discussion on the remapping of relativistic spacescapes helpful, Kawecki's view on field topology. This video is relevant because it provides a specific explanation of how the theory treats space as a navigable, tension-based field rather than a traditional vacuum. Would you like to explore how these concepts differ from standard general relativity?
Whoa, so you're an alien? Yep, I am. We live from a planet far away. That's amazing. So I guess Jesus created you too? Jesus? You know Jesus? We love Jesus. We love that guy. So you know Jesus too? Yeah, he comes to visit our planet once a year. What? We've been waiting ages for his second coming. Yeah, we invite him for cookies and cupcakes every single year. But what about you? What did you guys do for him the first time he came? Oh, come on, tell me. What'd you guys do the first time he came? Why isn't he here anymore? What happened? We killed him.